Hello folks. In this video, we're going to continue our Breakout project. And here we're going to solve a number of the issues that we left off with last time. Primarily, we're going to deal with the issue of collisions. So if we go test our game here, we see that the ball goes continually off the game screen, and the paddle can continue left and right, and the bricks are not destroyed when the ball goes through them. So all of that is handled or talked about in more detail in the last video, but this is just to review where we are currently. So let's go back to our code, and we're going to be adding a number of things and primarily turning physics and collision on for these game objects. Now, physics is built into the phaser package of functions. So phaser is going to handle that for us. We don't really need to code physics and code collisions. That comes with phaser. What we need to do is tell phaser what objects need to be colliding with each other. All right, and most game engines are like this, right? So if you're dealing with a video game and you're dealing with the issue of collisions, basically we import 3D models and 2D images into the game, and then we have to tell the game engine, we have to tell it where to draw the box around, right? Where to actually surround the object with a collision box so that it knows if those two things are intersecting with one another. Two objects, both with collision boxes, where they're intersecting. So we need to turn that on. And so what we'll do is we'll go back to our create function create. And I'm going to go below where we added enable player movement. And it's here that I'm going to add a new comment. And I'm going to say add world collision. Okay, and what we're going to do there is we're going to set the two things that can collide with the outside world. And for that, we're going to talk mainly about the ball and the player paddle, right? So we could do player, set, collide. I did call it player, right? Let me double check. Yeah, player. Okay, yeah, player and ball. Okay, player, set, collide, world, bounds. True. And what that's going to do is, actually, let's set ball to set, collide, world, bounds. Make sure you're watching your capitalization here to make sure it matches mine. All right. It's camel cased, so set should be lowercase and everything else should be uppercase when we type it out. So what's that going to do? Well, basically, it's going to set the collision to be the game space. And so basically anything that it was black on this screen is technically going to be the game space and will be collided with. So we don't have to set X, Y properties. We already did that above when we set the actual size of the play area. And so what phaser is going to do is it's going to go and it's going to get those values for us. So we don't have to worry about that, which is pretty handy. Okay, so let's run it here and find out what happens. Refresh. Okay. And okay, good. So we see that now the player paddle and the ball are both bound by the edges of the play area, the play space. You want to make it bigger, just make the play space bigger. But what we know is that the ball stops, right? So this is not desirable. We want to make the ball bouncy. So let's go below where we just added that code, and let's do make ball bounce. And that's easy. All you have to do is ball set bounce, and that's a function, so it's going to take in two parameters. And what we're going to do is we're going to tell phaser how much velocity we want to maintain after colliding with an object, right? So we want the ball to bounce, and this is just simply the velocity on the x-axis and the velocity on the y-axis. So I'm going to set 1 and 1. We're going to maintain it at 1 and 1. Basically take its velocity and times it by 1. Okay, so if we want to speed it up, we could set this to be higher than 1. If we want to slow it down, we set it to be lower than 1. Okay. All right, so then what else we got? Let's go back. Let's run it. Let's take a look. We test to make sure everything is working properly. Okay, good. And now it's directly heading back towards me. It should go through the paddle, and it does, and it bounces off the bottom of the screen. Now, if you ever played Breakout, you know that when it hits the paddle, the idea is that the paddle is bouncing this ball back up into the air. So, you don't want this thing traveling through the paddle. That sort of defeats the purpose of the game itself. So we'll handle what happens when it goes down, and like we'll add like a game over screen and or game over text. But for right now, we just got to solve the issue of that paddle going through the ball going through the paddle into that space below. So let's go back and we're going to let's disable bounce on bottom of screen. Okay, and this one we want to maintain x and y velocity, except this physics world dot check collision. So basically, we go to the physics library there. We go to the world object, which is our space, and we do a collision check. So in this case, if it's down, check collision down, and we can set it to be false. What that basically means is that the ball will not, we can go back and play it and try it out. The ball should not fall, should not bounce off the bottom of the screen. Let me refresh here. Okay, we launch the ball up. It should come back down and go right through the black line down here and go into the negative space. There we go. Okay, good. So that works. So now what we can do is we don't want it bouncing, but we can do a check on that collision later on, or a check for its XY value, and make sure that if it falls below there, we can go through and basically tell the player that, you lost. Okay, next up is we want to add in brick collision. So we have it colliding with the world. Add brick collision. Okay. And with this one, we'll start off with this physics. All right, and then we're going to do add. We add this physics anytime we're adding. You see it up here as well. This physics world. Anytime we're adding, or we're using the physics functions inside of the create function. So this is a function within a function, right? So we go this physics add, and then we could tell what we want to add. We want to add a dot collider. Okay, then we add some parentheses here, and inside here, what it's going to do is, if you look at the documentation, it's going to tell you more detail, but I'll run through it with you here. There's going to be, let's see, 5 parameters for this one. And those are going to be, the first one is, what's the first thing we want to check for a collision, right? Or basically with collider is it's going to be able to have us run a function as a result of the collision. So we have to tell it what 2 objects we're going to detect a collision between. So ball and blue bricks. So so the first thing is the first object. The second parameter is the second object. The third thing is the function we want to run when these 2 things run into each other. So I'm going to say destroy brick. This is not a built-in function to Phaser. We have to write destroy brick later on, but for right now, we could just type out the name and we could define it afterwards. You could literally name this anything you want. Destroy brick, destroy, remove brick. It doesn't matter. We're going to name this later on. So right now we'll call it destroy brick. The next one is has to do with the callback function here and the object we're referring to, which is this. So right now, if you're going to add your own colliders, just put null this for the future reference. And this is something a little more advanced that we're not going to be touching on right now. For right now, basically, if you did these 3 with a collider, you'd be able to detect most collisions and do things as a result of it. So here we're going to do object 1 ball, object 2 blue bricks, and destroy the brick. We're going to add this same for all 3 brick groups. This physics add collider. We tell it the things we want to collide. Ball, red bricks, destroy brick function, null, and this physics add collider ball. You can copy paste this too as well, I guess. Yellow bricks, destroy brick, null, and this. Okay, good. So this adds brick collision. So now we have colliders with all of this. Okay, and All right. Well, let's see what happens here. Before I reveal more, let's do refresh. Okay, and we are going to launch that ball. Why is it not working? Did I mistype something? No, this, no, this, no, this, no, this. For collider, this physics add collider. Let's take a look. Yep, destroy brick. Ah, duh. All right, so destroy brick's not defined. Yeah, so if you go to test this, it's going to yell at you. That's right. We have to define destroy brick. Okie dokie. So let's go all the way down to the bottom. I'm going all the way past function update, way down the bottom here. And what we can do down here is add brick collision function. Okay. And so this is going to run as a result of that collision. So what JavaScript was doing for us was when we loaded up the game automatically went to the function create, went down through all the list of things that it was expected to do, got to that part about the collision. And how collisions work is even though it was the function create and the function create runs once, collisions are being detected every frame. So if you're running your game at 30 frames per second, okay, your screen's refreshing 30 frames per second, that collision is happening at 30 frames per second. Now we'll get to collisions in a separate video about like the complexity of these things, but we have to watch out, right? Because too many collisions, the computer's always looking for them. So here what it was looking for that collision and it said, okay, I don't detect a collision, but I have no idea what this destroy brick function is. And that's what it was yelling at us about. So let's add that function now. Function destroy brick. Okay. And we'll pass in two parameters. We'll pass in ball and brick. Okay. And these will be the things that we'll be detecting inside here. And so first thing we're going to do is disable and hide body. Okay. And next we can go and do brick dot disable body. Watch your capitalization there. And true. True. So what are we looking at here? Disable body is a built-in phaser function. And we're doing it to the brick object. Now, how does it know what ball and brick are? Well, it has to do with what we set up here. So with physics add.collider, we called the first object was the ball. Second one was the yellow bricks. Yeah, okay. So we set the group that we want to have this be applied to. And then we told it the function to run as a result. Now, because this is a callback function, all right, that's what it's called. It's called when this function's called, so it's like a second thing that's called. And with the collider, what it's doing, it's basically passing this as a result of the collision, and we can pass in parameters because it's looking for parameters. It's built into phaser, it knows. And as long as ball is in the same order, ball and brick are in the same order that they are up here, ball, yellow brick, right? As long as these are in the same order, down here, we can use them. So essentially, we could replace brick with object 2 if you wanted to have it make more sense. But basically, object 1, object 2, and in this case, it's the brick. Okay, object 2, let's disable the body and true and true. So what are these two trues? The two trues are going to be the disable it, okay, meaning that no physics can be applied to it. And the second true is hiding it. So in our case, we want to disable the brick, meaning we don't want the ball to continue bouncing off of it once it collides with it or go through it or anything like that. We want to disable it for having any physics applied to it. And then we also want to hide it from the screen so it's no longer there. The image will still be loaded, but we're simply just going to basically do the CSS property would be like display none. We're just gonna hide that element from the user. Okay, so we're going to do that. That will disable that brick on collision. And so what else are we going to do? Well, let's take a look at what runs and we'll go from there. Okay, so we see it go up, hits the brick, and stops. Maybe that's a bug. Let's see. Goes up, hits the brick, and stops. So why is it stopping? Well, it's a physics object, right? So if you had a tennis ball and you gently rolled it across the floor and it hit the wall, if you rolled it slowly enough, then when it hit that wall, it would lose its velocity and it would come to a stop. So here we're seeing the same thing. The ball goes up, hits the bricks, and loses all of its velocity. So what can we do to prevent that? Could we increase the velocity? Well, we could try, but I guess there's two different ways to solve this, right? We could try increasing the velocity, and maybe we try that. Let's go back here and let's do ball game start, ball set velocity to -200, space down. Yeah, we can increase this velocity. Let's do -800. Let's launch this thing. So this is a test. You don't have to mess up your code. I can show you what's going to happen on mine. Let's go back. Let's refresh. Okay, and we see even with an increased velocity, even with a bounce, this thing is not, it's not doing anything. All right. So we can go inspect element and take a look and see if there's something that's wrong here. Okay. Nope. It's doing everything we asked it to do. And it doesn't matter how much we increase the velocity here. We'll set it back to its original one. It doesn't matter how much we increase the velocity. Hitting that wall is going to cause this to stop. All right. The arcade physics engine built into Phaser, okay, models the impact collision that collision has on velocity by default, right? So how do we get around the fact that the any type of collision is going to result in a loss of velocity? Well, we have to increase that velocity once again, okay? So we can do it a couple different ways, but we can take a look. Increase ball velocity on impact. That's our goal. Okay. And we can do let's do a check for the velocity of the ball. So we get access to that by doing ball.body.velocity. And that has two properties, x and y. We could take a look. If the ball velocity of x, we do 3 equal signs and then 0. If it's equal to 0, basically if the ball has stopped moving, we can do a couple of different things to rectify it. So let's just do ball.body.set velocity x, and we'll increase it to 150. Let's see what happens there. Let's run it. And go back here, exit out of that, refresh. Okay, goes up, hits it. Okay, bouncing around there. Now, what we don't see is what happens if it goes above. So let's see if I can get this thing to work here. We'll make it past that. Nope. So the fact that it doesn't go up any further, we're going to handle that in a second here. But yeah, so this is what we don't see is it's going up and it hits the box there. Right, and basically, but there's it's always going to go that way. Let's see if I can make it go the other way. We're here. Yeah. So what we don't have is a way to make it go the other way. So think of x and y, right? Yeah, we could set that velocity to be anything. I'm going to show you why this works in just a second here, but we see it always go to the right. And so what happens if sometimes it goes to the left, right? So we have the velocity go up, it hits that brick, and here we go. It hits that brick and it always goes to the left, but we sometimes want it to go right. And when, this is just an x value, right? So x to the right is increasing, moving x to the left would be, we put a negative number, it'll move to the left towards 0, okay, and be stopped by the world. So we want to give it a chance to come up with a sort of like a randomized solution to that. And we could sit here and try to like mathematically figure all this out, but at the end of the day, physics, remember, physics in a game engine is pretend, right? I mean, there are no real physics in a game engine. There are no physics in the game world. Anything we're adding to this is fake. And when you design games, you should not be afraid of faking it. What you're creating is not a representation of reality. I mean, yes, it's not meant to represent it truthfully reality. You're trying to come up with a interpretation of reality. That's all, right? So you could do a lot of things in games you can't do in real life because it's not real. And therefore, because what we're making here is almost the same as like a theatrical production, okay, the illusion of reality is just as good as reality. So we want to be able to set the ball going left or right. Is it, are we going to take this down to the molecule level and molecular level and try to mimic physics? No, what we can do is we can just do another if statement. Let's do random num is equal, we're going to access the JavaScript math functions. So math and random. Random is going to get a number 0 to 1. Okay, so it's a decimal number. Okay, and what we can do is we can do a check on if the random num that we get is greater than or equal to 0.5. Let's set the ball velocity to 150. So basically, we're going to roll the dice on this one and say, okay, well, if the number we generate is higher than 0.5, and you can, I mean, math.random to make generate like a number larger than 1 is a bit of a pain, so 0 to 1 sounds good to me. Random is larger than 5, we'll set the velocity 150. If else is going to be literally every other scenario besides 0.5, so 0 to 0.4, 0.4, 99999. Else we'll do set ball dot velocity ball dot body set velocity x to be negative 150. Okay, so we're going to move it in a left or right direction dependent upon where it hits and like a random number being generated. So basically, it rolls a dice, and depending on what that number comes up with, it's going to move it left or right. So if we go and we run it, and I refresh, now we see it go up, and now we should be able to see it goes left. Cool. So now we can see it go left, and we can see it go right. This is pretty neat. If we refresh, I'm just going to do this a bunch of times on impact. Yep. So it basically rolls a dice and gives you illusion that it's going left or right because of some chance that it hits and hits it in a particular way. To the user, it doesn't matter. To the user, it looks normal. But to you, behind the scenes, it's just randomly saying, okay, pick one or the other and go with that. Okay. So now we have the ball going and it is colliding. It's working perfectly. Okay. There's a couple things left to do, and that's going to be solving the issue of the brick collisions. Okay, why is it just going left and right and bouncing, and why isn't it going up and down? But we added the velocity again. That solved that issue. The ball's still moving, which is a good sign. But things we haven't handled yet are collision with the bricks. How do we make it continue bouncing? And the paddle. Those will be coming up next to solve for those issues. And then we'll get to what happens if they go below the screen, and what happens if they knock out all the bricks. So we have to add a win and lose screen as well too. But we'll stop there for now. Thank you for watching, and I'll see you in the next one.